Whether you realize it or not, you've already been working with linear combinations of vectors, and in this activity, you're going to be working backwards from you'll be given the linear combination, you'll be working backwards to find the values of a and b. So it starts out with a pair of vectors. In this case, u is 2 and 1, and v is 3 and negative 2. And we're going to be taking those vectors and adding them together and perhaps multiplying them and then adding them together to give us a vector w. Now when a is 1 and b is 1, this is fairly straightforward. 2 plus 3 is 5, and so w has an x value of 5, and 1 minus 2 is negative 1. And so that was the very simplest linear combination when a and b were 1. Now you've already looked at au plus bv being equal to w when a and b had different values. Geometrically, this is what it looks like when a is 2. So in this case, I can just move my slider and see what happens geometrically. And when b is 3, I wind up with a resultant that's 13 and negative 4. Fairly easy to look at geometrically. Algebraically, how does that work? Also very straightforward. I can get my x value just by multiplying 2 times 2 plus 3 times 3, and I end up with 13. I can get my y value by multiplying 2 times 1 plus 3 times negative 2, and I end up with negative 4. Also very straightforward. Simply doing a linear. What's going to happen, though, if I know my two vectors and I know my resultant, but these sliders aren't conveniently in the picture, and I have to figure out what a and b are. And so a and b just mysteriously change as if by the hand of God. And what I need to do is figure out what they were based on all the information that I have. And so I know my w is 4 and negative 5. I know u is 2 and 1. I know v is 3 and negative 2. And I can probably look at this geometrically, and I can actually figure out what's going on here. This is pretty obvious what a and b are. However, we are going to learn how to do this algebraically, and it's relatively quick. And so here I go. I'm going to find a and b from the original vectors and the resultant. I'm just going to work backwards, and I'm going to be using elimination, although you can use substitution if you like. So there we go. I know that a times 2, 1 plus b times 3, negative 2 is 4, negative 5. And so if I want to make an equation of that, and I will, 2 times a plus 3 times b, in other words, the x values, have to equal 4. I'm going to call that my equation 1. Okay, very straightforward. I'm going to call that equation 1. And also, 1 times a minus 2 times b is equal to negative 5. And so there we are there. Now I have two equations and two unknowns. I prefer to do elimination on this. Now for those of you who forget about elimination, it's all just a matter of getting these coefficients the same and then subtracting the equations. And so in this case, I could just hammer this. I could do 2 times equation 1, and then this would become 4a plus 6b equals 8. And I could do 3 times equation 2, and this would become 3a minus 6b equals negative 15. And then this says subtract, but since it's already negative, I could just add the two equations and I would eliminate b. Of course, there's a much more obvious way to do that, and that is just to multiply equation number 2 by 2, like that, and then I'm going to subtract that result from equation number 1. And I have effectively eliminated a, and now I can figure out what b is. 3b plus 4b, notice the sign changed, equals 14, or 7b equals 14, so b equals 2. Once I figure out my b, it's just a matter of substituting to figure out my a, and then algebraically I have my vectors.